All right, yeah. So let's look at these 5 questions. The first question, yeah. Question number 6. Yeah. So let me bring up the review file last time. So this is a review file last time. And we look at the, yeah, MQ4. Yeah. At the end, yeah, MQ5, yeah. Right, MQ6, this one, yeah. So second order non-homogeneous, yeah, because we want to use the choice rule, right? Yeah, so MQ6, we want to use the choice rules. All right, so let me give you the specific information about the choice rules. Yeah. What kind of question? How do I plan to test you? All right. In our homework question, we have one similar question. Look at this question. Question number 7. Okay. This is the sample question for our MQ6. MQ6. Okay. All right. Oh, sorry. Yeah, this is 1, but the one I plan to use, yeah, although this one we can use the choice rule, right? Yeah, because here YP you write in this way. Yeah, that's by the choice rule. Okay? Yeah. This one is by the choice rules. Yeah, but this is a simple way, we call it basic rules. Yeah. So this is the, we apply the basic rules. There are 3 rules. Basic rule. There are 3 rules there. So this is the first one. Basic rule. All right. But the one I want to give you a test question is another one. So yeah, this one also by choice rule. Okay, this is another sample question. Sample question for MQ6 by choice rule. Okay, yeah. So here, method 1. Method of variation parameters. Most of you use this method. Yeah. I look at several students, look at your work, several students. Most of you use this method. Yeah. That's okay. But I want so the second method. So here we want to focus on the second method. The second method we use the choice rule. Here by the choice rule, and we use the modification rule. That's our number 2. Choice rules number 2. That's the modification rule. Yeah. Okay. So what's that modification rule? Yeah. Let me. I took the screenshot. Yeah. So this is screenshot. Screenshot of our module 2, part E. Part E, module 2, and page 3, yeah, choice rules. Yeah, I took that screenshot. Yeah, so there are 3 rules: A, basic rule; B, modification rule; C, sum rule. Okay, yeah. So now the question: modification rule. If a term in your choice for YP happens to be a solution of the homogeneous OD corresponding to 4, yeah, homogeneous corresponding to 4, equal to 0, yeah, 4, multiply this term of it. Yeah, so that here it means, all right, in your Rx function, Rx function, yeah, because there could be some e certain number of x, right? Yeah, lambda x. But this lambda 0 happens to be a root of the characteristic equation of that homogeneous plus a plus b. Happens to be the root. Yeah. To be a root, there are two cases. One is single root. Single root, because if it's a root, single root, one is a single root. If it's a single root, then you need to multiply by x. If it's a double root, you need to multiply by x squared when you choose yp. Yp, okay? That depends on single root or double root. Okay? Single root, for example, it should be c, yeah, some undetermined constant c times x times e to the that lambda 0x. Okay? Yeah. Yeah. And later you may add some other things. Yeah, but this part like that. So the single root. Single case and a double case. If it's a double case, your yp c times x squared times e lambda 0x. You know, other part, because other part you need to look at your R function if you need to add some other things. Yeah. All right. So that's the modification rule. Okay? That's the modification rule. Yeah. All right. So based on this modification rule, now let us go back to this question. Yeah. Yeah, this question, right? This question, the characteristic equation. Yeah. Yeah. All right. So the characteristic equation and this R of x. All right. Then our y0 equal to, this is a double root. Yeah, because this equals y minus 2 squared equals 0. So it's a double root. Okay? Double root and e to the 2x, yeah, y0x, 2x appears in the rx function. Yeah? So here, same. Then, based on our choice rules, modification rule, specifically, yeah. So our yp function should be constant c times x squared. Yeah. Double root x squared. Okay? Yeah. From the double root. Right? Then, you know, yeah, so that the main part of the R function, yeah, we need to determine that capital C. Yeah. All right, so then you, in this way, you get an appropriate form of yp function. Then you take the first derivative, second derivative, then you do the calculation. So after simplification, you get this expression. And this expression should be equal to our given function. Our given function is this: 6 e to the 2x over. Sorry. Yeah. Yeah. So yeah, sorry. This should be fourth, right? Yeah. I will correct it. Yeah. Because the cancellation, let's look at cancellation. Minus 4 cancel out. Okay? All right. Then 1 over x squared term minus 4 plus 2 cancel out, right? Cancel out. cancel out, cancel out. Then the remaining, the last term left, this term, and 2 times 3, 6, but it should be x to the 4th, not x squared. Yeah, so I need to change that. That equals to x to the 4th. This is our function. Then, so c equals 1. Yeah, because 6c equals 6, c equals 1. So yp equals this. The same answer as we did from the variation parameters. Yep. So variation parameters, we get the same answer. Yeah. Yeah. But here, yeah, we like to use the method of choice rules. Okay? Yeah. Yeah. So this example, I want to give you our number 6 question in the midterm based on this question. Okay? All right. Yeah. Then, how do I plan to do? So, in my idea, how do I plan to do? Yeah. Let's look at question number 9. Another related question. Okay? So this is question also. You can see this question is very important. Yeah. Another sample question for MQ9, MQ6. Sample question. But this one, order 4. Okay? Although it's order 4, but its characteristic equation is pretty simple. You can do the factorization minus 2 plus 2 minus 3 plus 3 equals 0. Single roots. So here you have 4 single roots. But e to the lambda, yeah, here I use j, e to the lambda jx does not appear in the R function. So then your choice rule, you just have that form. That simple. Yeah. But in our midterm questions, yeah, so here, now we get to our midterm question. Our midterm question. Question number 6. Okay? All right. Now, important idea here. Right. I want to give you a 4th order ODEs. Okay? 4th order ODEs. So you expect to have 4 roots, right? 4 real roots. Yeah. So here, I give you 4 real roots. Yeah. I do not give you complex roots. 4 real roots. All right. But the 4 real roots should be in this way. With 4 real roots. But these 4 roots should be like this. 2 single roots. 2 single roots. And 1 double root. Okay? 2 single roots and 1 double root. So adding together, including the multiplicity, so you get a 4. Okay? You get a 4 total number of roots, including the multiplicity. You get a 4. Then, so that is the left-hand side function. Right-hand side of the R function. right hand side, I need to give you Rx. R of x. Yeah, so here. R of x should have two terms. Okay. Two terms. T1 plus T2. Two terms. Because two terms there, you need to apply. Yeah, let me show you this choice rule. Number C, sum rules. See, sum rules. Sum of functions. Yeah. So you look at each term. So you have a, specific form representation. But you have two terms, so you write out, desired forms for each term, then you add them up. Sum rule. Sum. You take sum. You take sum of those two forms. Yeah. All right? Yeah. So sum of functions. Yeah. Choose. Yeah. But you need to add them up. Okay? All right. So that's one. All right. T terms. T1 term. What I will give you contains a single root. Okay? All right. Then T2 terms contains a double root. All right? Yeah. So for a single root, you know how to write the desired expression, right? Yeah. Yeah. For example, C1. Or if you use AB, it's okay. Yeah. Not necessarily always C. If you use A, for example, YP. A times, because single root, you need to multiply x, right? Yeah. E to the lambda 1x. Yeah, that's the single root structure. Yeah, if there is some other things, sine, cosine, you may need to include. Okay, all right. Then T2, B, because it's a double root, so you may need to use x squared e to the lambda 2x. Right? Yeah, 2x. If you have sine, cosine, something, you need to include like that. Okay. So that's the way you apply the choice rule. Yeah. Yeah. This is, something in my mind. I want to check your understanding for that choice rules. Okay? Yeah. So that's this question. Yeah. Yeah. Because, you need to understand this way. Yeah. Okay? Do not use the variation parameter way. Okay? Because variation parameter way, too much calculation. Too much calculation. Oh, yeah, because most of you, so for the question like this, so I plan to give you that. The question like this, think about, the variation. Because here, I give you the fourth order, right? Fourth order, if you use variation, our formula is for second order, right? But here you have a fourth order equation. Yeah. Fourth order. If you use the choice rule, you can still use the choice rule. Okay? Yeah. Because why you can still choice rule? choice rule is used so you can find the YP, a particular solution. Yeah. Because the homogeneous 4 solution, you already know there are 4 homogeneous solutions. You already have them. Right. Then you use choice rules to determine YP. Yeah. But variation parameter, because you have 4 homogeneous solutions. Yeah. So if you want to apply variation parameter, that's too much work. Yeah. Too much work. And we didn't talk about how to solve the 4th order ODE by the variation parameter method. Okay? Yeah. So you should use this method for 4th order. All right. So that's this question. The next question, let's go back to the one last time. Laplace transform, solve ODE. Yeah. And this one is, we have a lot of examples. Yeah. Yeah. So this one, I think, I do not need to talk too much, just as the usual way, right? So here we also, I think we have some Laplace transform. Yeah. Oh, here, right. Yeah. Here, right. This one, okay? Yeah, this one, Laplace transform to solve. Number 14, okay? So number 14 is used for MQ7, okay? MQ7, yeah? So you solve Laplace transform, yeah. Hopefully the calculation is, so here, you see the calculation, a lot of work. Yeah, calculation. Okay. Yeah. So I try to make a reasonable calculation. Okay. Yeah. Yeah. Try to make a reasonable calculation. Yeah. Not too hard. Okay. Not too hard. Yeah. Yeah. I want to make it easier than this one. All right. This looks pretty hard. Yeah. Okay. You need to do calculation quite a lot. Yeah. So I want to make it easier than this one. Okay. Than this one. Yeah. Right? Yeah. But similar, but easier than this one. So that's question number 7. Okay. All right. Next one. Question number 8. Yeah, here, calculate inverse Laplace transform. Yeah, so we also have a sample example. Yeah, let's get here. Yeah. This is inverse, okay? All right. So this is the sample question for MQ8. Yeah, inverse, okay? Yeah. So this one, yeah. So the one what I plan to give you it should include both the first shifting theorem and the second shifting theorem. Okay. So yeah. So that's the my main requirement. Okay. Yeah. Other than these 2 theorems, just basic formulas. Yeah, basic formulas and what's next? Right. Another is the fraction split, right? Split fractions. So you need to, because here we split fractions a lot, right? Yeah. So another thing what you need to do, split the fractions. Yeah. If you want to use, partial fraction way, it's okay. Yeah. But you need to split fractions. Yeah. You need to split fractions. Okay. Yeah. I talk about how to split in several classes. Yeah. I talk about that. But I believe some of the students, you may not be able to master those methods. Yeah. Yeah, if you can not understand that method, then you just use the way that you can handle, okay? Like a partial fraction method. Yeah. What? Yeah. All right. So that's the MQ8. MQ9. That's good. Yeah. 2 word problems. The last 2 word problems. Yeah. All right. So MQ9, undamped forced oscillation with resonance. Yeah. So we have a similar example here. Yeah. Yeah, something like that. This one. Right. This, not that. Yeah, not here. Not here. Then, yeah. So we have an example. Yeah, in our notes. Yeah. So here I didn't give you an example here. Yeah. Although similar to this one, but not quite. Yeah. Similar to this one, but not quite. Yeah. Okay. Yeah. So I do not want to say, this one is the MQ9. Yeah. Yeah. Right. Right. Okay. Yeah. All right. So MQ9. Yeah. So that's the C notes. Okay. MQ9. C nodes. Okay. Yeah. Yeah. But the MQ10 should be here. Okay. MQ10 should be here. MQ10, RLC circuit. Yeah. MQ10. RLC. Yeah, this one. Okay. Yeah. Yeah, this one no R. Yeah. So okay. Yeah. So we need to add R component here. Okay. Yeah. R component here. Yeah. So we get a RLC circuit. Okay. R component. Yeah. So you have that R term. Okay. That R term. So this is for our MQ10 question. Okay? Yeah. Yeah. Right. Yeah. Yeah, and you can use Laplace transform to solve it. Yeah. Yeah. All right. Yeah. So that's those 10 questions. Okay, yeah. So the detailed information of those 10 questions. Yeah. Yeah. So I implement that plan. Yeah. So I plan to give you tomorrow morning. Yeah, tomorrow morning. So here, let me tell you my plan, because tomorrow, Friday, right? So Friday start. Yeah, but based on my current schedule, so I want to let you know my detailed plan a little bit. Yeah. Because I'm also running a midterm for my another class, algorithm class. Yeah. In that class, I need to post 5 challenging questions for their midterm test. Yeah. Also, I need to post it tonight. Yeah. So the first thing tonight, I need to make those 5 challenging questions for algorithm class. Algorithm I gave them yesterday, the midterm. I gave them yesterday, but yesterday I gave them the basic questions, not challenging questions. Yeah. So Friday, I need to give them 5 challenging questions. Yeah, but I need to make those 5 questions tonight. Yeah. So that means tonight I may not have much time to make questions for our class. Yeah. But I can do half of it. Yeah. So tonight I plan to make the first 5 questions of the midterm. Okay? Yeah. So tonight I can get the first 5 questions for the midterm. Yeah. So tomorrow morning you can see the first 5 questions. Yeah. Then tomorrow afternoon, yeah, sometime, then I will give you the remaining 5 questions. Okay. So what do you see? The first, it's a incomplete version, half version. Only 5 of 10 questions. Yeah. Tomorrow morning. Yeah. Then you just work on those 5 questions. Yeah. But after I complete it in the afternoon, yeah. Yeah. Most likely the mid-afternoon. Okay. Yeah. Most likely the mid-afternoon. So I post the remaining 5 questions. Yeah. Then you switch to the complete version. Okay. Yeah. Yeah. The half version, just you can work on it, but when you do your work, so you use the complete version to do your final work. Yeah. Yeah. That's the plan I'm going to do, tomorrow for our midterm. Okay? Yeah, that's the plan. Yeah. After I post all the 10 questions, then I will complete grading for homework assignment number 2. Yeah. So, yeah. I need to complete the grading. So, yeah. So you can see after I complete it, you can see the graded results. Okay, in Canvas. Yeah. So, and at the same time, I post the solution file, and this annotated solution file. Okay, so you can use to study. Yeah. So that's the plan for the midterm. Okay. Yeah. Any questions?